so
Very good. They also had something called Putt. It's the same thing. It looks like a bullet though. It's like that. So they also mentioned in these documents the Super Orion interstellar arc, and it would have been an 8 million ton Orion craft with a 400-meter pusher plate, capable of achieving about 1/10 the speed of light. So it would have been a giant world ship. And in principle, this thing could have been built. It's just a matter of throwing money at it, right? Which is really great. That's why I love the Orion thing. Like, this is not, like, this is just our rationality, like, taking reality, you know? It's not, like, fantasizing at all. It's just, it's real. It could be real. It's just a matter of going crazy and spending lots of money. In comparison, though, the Queen Mary, I think this is actually wet weight, is 150,000 tons. So this ship is 10 times, like, more than that. The actual weight of the Queen Mary. So, like 10 Queen Marys launched on a giant nuclear fire out of Jackass Flats. Awesome. Oh yeah, there's a little, there's a picture. I found the actual picture.
The Brooklyn Bridge.
First shot. Yeah. I heard, so again, recapitulating. Oh yeah. I think the text speaks better than I do. So yeah, there you have it. Each of those would have been 10 megatons. The bombs.
Is that 0.1 to 1 cancer death per launch if you launch from the North Pole or if you launch or from
I
the
think
South
that's
Pole?
Jackass Flats actually. Because I think they realized that the South Pole, like, although optimal, was probably not going to happen. So they just said, you know, we can do anything with Jackass Flats. So,
Where are those?
I think those are New Mexico. New Mexico, and that's basically around where all the nuclear testing areas are.
Is that the people presence or is that like national cancer rates?
This is worldwide.
That's
Worldwide.
not
Oh.
Because keep in mind, like, it's blowing up bombs in the upper atmosphere as it's going away from the Earth, right? So this is going to be a widespread effect.
How do they calculate something as fine-tuned as 0.1 cancer deaths per launch?
I mean, you know, like, this is totally like out of your ass calculation. Like a Fermi problem calculation. I don't know. I actually didn't see the calculation. I just heard about it. But I encourage you. A similar design to Orion was Project Medusa. This would have achieved a higher specific impulse. If you recall, it was about 20,000 for Orion. And that was an optimistic figure, by the way. This would have actually used a sail to accelerate it, and the bomb would have gone off in front of the ship. Let's see. I'm not sure how they were going to make the sail survive that.
Yeah,
Would the
Like
ship have
adamantine.
would the ship have to travel through the shockwave then?
Yeah, there's a lot of problems I found.
It's so bad in
Oh,
space,
no.
so it's not going to be mediated very well.
I don't know if this was actually meant to carry humans or not.
Probably.
No.
If it's going off in space, you just put a radiation shield in front of this.
What about the sheer force of the shockwave?
Well, presumably there's not really much of a limit to how far ahead this thing can blow it up. As long as there's a cable attached to it. So they could very well be hundreds of kilometers that way, as long as the cable goes out and the momentum is transferred.
the cable will be being hit by, the deer or something.
Yeah, using carbon nanotubes. Okay. So we've been talking about fission pulse propulsion. Now we're going to talk about now we're going to talk about fusion pulse propulsion.
See.
This is actually much safer.
Yay!
in principle. Okay.
Yeah.
And
Does it feel like cancer?
these are also all of these ideas are much less developed. Orion is actually these are pulse nuclear. The fusion drive here is an enabling technology because it doesn't actually exist. So this would use these are ideas that don't actually use something that we actually have today. or does Orion use nuclear weapons? Well, these fission weapons which we have, because these wouldn't be actual fusion bombs going off. This would actually be controlled fusion. So it uses the pulsed fusion idea uses something called inertial confinement fusion. And the principle of fusion essentially is you want two nuclei to come together and form another nuclei, and the bonding energy gives you, that comes out of that. That gets liberated, ends up being quite substantial and much better than fission. And the actual problem here is if you look at the potential for an atom. So if you think about the forces that are going around an atom, you know that there are charged particles in the nucleus, protons. So you have an opposing field, right, an electric field, sticking away from it. But once you get close enough, the strong nuclear force takes over and dominates at very short distances. So there are four fundamental forces. There's the strong nuclear, the weak nuclear, the electromagnetic, and gravitational forces. And the strong nuclear and weak nuclear forces are forces that operate on very small distances, like 10 to the negative 13th centimeters is when they actually become noticeable, but they're also incredibly strong. And so basically what you want, and it's attractive between nucleons, which means that eventually when you get a nucleus from another atom close enough to another nucleus, they'll actually be pulled together with an incredible force, all right? But before you do this, you have to make it so that the protons in one nucleus and the protons in the other nucleus, which you know are repelling each other, you need to actually work against that until they get close enough for this strong nuclear force to take over. So if you actually graph the potential energy of the system here, well, the potential, which is different from the potential, you get something that looks like this. Things with something with a certain energy can only go as far as until the curve actually overtakes it. So you need something with an incredibly high energy in general to get in here. In other words, a nucleon that's going extremely fast. So generally, because of this Coulomb potential, you want to use nucleons with a very high neutron to proton ratio, because the protons are going to be the source of your repulsion. And the best things for this that are stable are helium-3 or deuterium. Helium-8 would be really great, but it has like a half-life of a few microseconds. But so nuclear pulse propulsion is something that is enabling technology for this idea. And experiments that are actually working on it want to achieve this using radiation pressure from a bunch of lasers all shooting at a pellet. And they'll end up confining it so that the pressure and the energy, which is actually going to be the kinetic energy of these nucleons, which you need to fuse, is high enough that you actually get sustained fusion. And these experiments use very awesome large lasers. These are the NOVA lasers. And this is actually a sample being hit. Well, this is an actual. So it's basically a very tiny pellet with the fuel in the center, and they shoot the lasers at all angles to heat it up and confine it because the lasers carry momentum. The light carries momentum, so it can't go anywhere and just heats up, and you'll hopefully get fusion from that. So there's an actual experiment taking place in the fusion chamber. All right. So after the fusion takes place, you end up getting a lot of very fast charged ions shooting out of this explosion, this very hot explosion, and these ions carry mass. So the idea is, if you vector these ions, which all have mass and momentum, out of a nozzle, you can use that to push your ship just like a rocket, just like a chemical rocket. And obviously, because of the efficiency of the fusion reaction, you're going to get much higher heat and much more energy, and so hence better momentum out of these particles rather than a chemical explosion. So one highly developed idea was Project Daedalus. And this would have been a a trip to Bernard Star. And the cool thing about this is, A, it would have been completely unmanned. B, since it's unmanned, you don't need to worry about stopping. So it would have just gone as fast as it could towards Bernard Star, shot by, taken some pictures, transmitted them back to Earth, and then it just keeps going. All right? No braking. It's really manly when you think about it. All right. So